Thank you very much. A very good afternoon, ladies and gentlemen, and a very warm welcome to our short presentation on the effective air pollution control equipment and systems for the manufacturing processes and the biomass industries. My name is AK Wu from Master Jaya. Our stand, our booth is just behind here. So after this talk, you can just walk to our booth, just immediately behind you. So it's just here. So please take a look at our booth and see what we have to offer you. I would like also to thank a number of my dear friends who come here to support me, like Lau, Carol, Eric, Duane, and where's the other Japanese friend, Murakami-san. So came all the way from Japan to listen to this talk. All right. The talk is very short. It's only 25 minutes, so I think I have to rush a little bit. Due to this rapid industrialization towards the developed nation by 2020 for Malaysia, we will exhaust the national fuel reserves in about 30 to 40 years, unless Petronas start to discover more oil fields. Otherwise, I think our reserve will deplete gradually. Yeah? And biomass waste has been identified as a renewable energy. So the type of biomass available in Malaysia are the following. They have wood chips, sawdust, anti-fruit bunch, dark rice husk, cocoa shell, palm kernel shell, palm fiber, sugar bagasse. I think I better stand here because otherwise I block you. And the type of air pollutants from the biomass combustion and also from the manufacturing industries are the following. You have either gaseous pollutants or particulate pollutants. I mean, this is the dust particles. These pollutants are in the form of gases, different kind of gases, right? And the gaseous pollutants will normally exhibit diffusion properties, formless, there's no form, formless fluids. They change to liquid or solid state by the effect of the pressure and temperature. For example, you have carbon monoxide, CO2, sulfur dioxide, SOx, hydrogen sulfide, all kinds of vapor, NOx, VOC, odor, smell, and so on and so forth. Right? And whereas the particulate pollutants are dispersed matter, such as fine and coarse particles, example, smoke, fume, mist, dust, and so on. So these are all two types of major pollutants that are normally generated in all kinds of manufacturing industries and also from the biomass industries. Right. Okay, these are the major pollutants that are emitted from the various processes. I do not want to go through this. Okay, next. Okay, the main thing is we want to talk about effective industrial air pollution control. Now, how do we control air pollution in the industries? All right. So there are three factors that we need to consider: environmental factors, engineering factors, and economic factors. So for environmental factors, we need to consider the equipment location, the available space, the ambient condition. In Malaysia, I think we have the same condition all the year round. The allowable emission limit by the Ministry of Environment, I think that's a very important factor that we need to consider. The availability of utilities like water, compressed air, power, and so on, in order to run the air pollution control equipment and system. And also sometimes the air pollution control equipment and system contribute to wastewater, land, and noise pollution when it generates noise because of the high power blower, and also it will generate some land pollution because the dust collected you need to dispose, right? And also sometimes it causes some aesthetic, what they call unsightly kind of tall chimneys along the way. So you also have to cover up some of this. Engineering factors are the very important factor that we need to consider for the design and the selection and the sizing of the dust control equipment. This is the job of our company, Master Jaya. We have to study the contaminant and the gas stream characteristics, the dust loading, concentration, and so on, the particulate shape and the size, the corrosivity and abrasiveness of the dust, toxicity of the gas, the air volume required to be extracted from the process, the type of control equipment to be used. And finally, of course, the boss, the owner, the end user or the investment company, they have to consider this. It's not only the capital cost, the operational cost, the maintenance cost, and the total life cycle cost. I think this is very important. So in selecting air pollution control equipment, I would advise that you should not only look at the capital cost, you should look at all these various costs. They will form, the total cost of the whole system. All right. So in Malaysia, especially in our context, local context, the two very important things is we need to comply with the regulatory codes and emission standards. That's the first thing for most industries to do. They don't care about it. They said they come to us and say that, look, we have a problem with our air pollution in our factory or with our biomass boilers, and we need to comply with the DOE requirement. Therefore, our design, our equipment must be able to comply with this first. And then the second consideration will be the lowest cost. Lowest cost is a combination of capital, operating, and maintenance cost. All three combined to form the lowest cost. So with these two combination, then you have the final choice of the equipment. I think this is a very, very important consideration for the investors. All right, I just like to show you a little typical layout of air pollution control equipment and systems. Generally, you can find this in the industry. This is what is currently used in the biomass boiler exhaust. So you have a boiler here, the flue gas with the dust and so on come, and it goes through a multi-cyclone equipment, and finally go into the ID fan, induced draft fan, and went out to the stack. So currently, this kind of system now is no longer able to meet the standards of the DOE. See, the DOE is getting more and more stringent. So in the new regulations, this equipment is no more able to meet the level here. Currently, I think they are talking about 200 milligram per cubic meter of air. That means 200 milligram of dust allowed to be emitted in 1 cubic meter of air at the chimney here. But they are going to limit it down to about 50 milligram, from 200 down to 50 milligram. So it's going to be very stringent, and the multi-cyclone certainly cannot do it. So we have to change this now. Either there are many ways of improving the existing emission standard by adding an electrostatic precipitator after the multi-cyclone, so that the fine dust, because this equipment here is only able to collect the coarse particles, not the fine one, only the coarse one. So the fine particles will go further downwards, and this will be trapped by the multi-cyclone here, right? And by the electrostatic precipitator here, and eventually it goes out to the ID fan and to the stack. Now this emission here will be very good. You will be able to comply with the 50 milligram. It's not a problem. Okay, next. The better way of doing that is this. Of course, this is very elaborate. You can see that we have all the equipment, necessary equipment to ensure that the operation will be able to run for years and will be trouble-free. So you can see here that the existing system has a multi-cyclone. We added a quenching tower because that is very important to reduce the flue gas temperature. And before that, before the back filter, we add on the reactor. That is, in case if you have got any SOx or NOx, we can remove this by having a reactor to add in some reactants to react with the gases to remove those harmful pollutants before it goes into the back house. So the back filter remove all the remaining dust in the flue gas stream. So finally it comes out to the fan and to the stack. Here we can achieve less than 50 milligram. Some customers, they demand even up to 10 milligram. They say, I want 10 milligram because that is the world standard. In most of the industrial advanced countries, they have this standard now. So we are able to design system to meet our Malaysian standard as well as to the international standards. Okay, we have another alternative to those three that we have mentioned. We can also use a Venturi scrubber and a packed tower scrubber to remove the pollutants coming out from the boiler so that you can also comply with the regulation. But this system has a little setback. That is, the packed tower scrubber will remove the air pollution, but it will turn into water pollution because the dust will then become slurry. So this slurry has to be drained from here, and it has to go into a wastewater treatment pond to be further treated before the water can be discharged. So that is an added cost. So most industry would prefer to have a dry system, like those earlier one that I mentioned. So the dry system, I think, is still the best. Okay. So we just said earlier, what we want is, what do we mean by effective air pollution control system? First, we must meet the DOE and the DOSH standards and the requirement, right? You must get the approval from the Department of Environment. That is the most important letter. The certificate of approval from DOE is where you hang up in front of the reception, so that any DOE officers come into your office, you show them that we got approval letter already. So you don't have to come and catch us, all right? Then you should have the lowest running costs possible, and it should be able to run continuously without problems, because air pollution control equipment system is a very costly investment. Sometimes it can cost up to as much as 1 million, 5 million, 10 million, even 50 million. Huh? So a big installation can cost a lot of money, and therefore you want the plant to run continuously for many, many years without problem. And there will be no complaint from the operator, your own internal operator, and also your neighbor. Because if the plant doesn't run well, if you still emit dust, your neighbor will complain. The community, the surrounding community will complain, right? And you want to have longer lifespan. So these are the main parameters that you should consider if you want to go ahead with any kind of air pollution control equipment. All right, there are various types of air pollution control equipment for biomass combustion and also for the industries in general. So we mentioned earlier, we have the cyclone and the multi-cyclone, the back filter dust collector, the electrostatic precipitator, the venturi pack tower scrubber. And so cyclones, you can see from here, is a pre-collector. I don't want to go into detail because this can be a little bit technical, but basically the function of this cyclone or multi-cyclone is to remove the coarse particles from the airstream, or sometimes it act as a separator, or even act as a spark arrestor. So in many operations or in many processes, it generates sparks or flame, and you need to trap this before it goes into the backhouse. Otherwise, the filter will be burnt. So that is to protect the downstream equipment for the cyclone. Okay. Okay. This is how it works. It comes in. You know, it go through. Okay. Next. Then you have the back filter dust collector. This is the most efficient. You can see for dry fine particles, the efficiency can go up to as much as 99.9%, or even 99.95 or 98%, depending on what you want to do. Huh? So this is a very efficient and the most commonly used dust control equipment in the market. Not only in Malaysia, in the whole world. This is the biggest market. Okay. Then here you have the electrostatic precipitators, a very huge equipment. Normally this is used in power plants, coal-fired power stations, in the incineration plant, in the steel smelters, and so on and so forth. Right? And in Malaysia, we don't have many of this because this equipment now also is gradually replaced by back filter, because the efficiency of the EP, we call it EP or ESP, is not as good as back filter. Back filter will give you the best filtration efficiency as compared with even this. This is the principle of how it works. The dust are actually electrically charged, all right, and then it will be attracted to the collecting plates, which is positively grounded, and then as the air goes through the chamber, the dust will be collected here, and as it passes by, the clean air goes out to the stack, to the fan and to the stack. So this is how it works. Huh? It's just like your ionizer in your home, you know. Same principle, except the electrostatic precipitator is a big unit. It's an industrial unit. So, but the principle is still the same. Okay, you also have venturi scrubber, which is the wet collecting system. Is from medium to high efficiency. Is normally meant for wet, hot, and sticky dust, but it has a bit of higher pressure drop, and you need water to scrub. Then it also produces slurry and wastewater. So as I said earlier, I would advise the installations to go along with a dry system rather than a wet system, because if you go for a wet system, you generate slurry and wastewater, and you need further downstream wastewater treatment plant, and that will cost you also a lot of money. Okay, this is how it works. Go through the venturi, and go through the cyclone separator and comes out. Dirty air go in, clean air comes out. Okay. Next. Okay. All right. I think I want to cover a little bit about Environmental Quality Act and the Clean Air Regulation 1978. Okay, so this applies to all the industries, every single industry, irrespective of your location. I know that some of the industry claim that they are in the very remote area, far away from the town or from the villages, in a jungle, therefore they don't come into this regulation. No, it's not true. Every single industry, as long as you've got any premises used for industrial or trade purposes, on which matter is burned in connection with any industrial or trade purposes and so on, burning of waste. Any facility that discharge or capable of discharging air impurity into open air. Every chimney, every industrial plant, every fuel burning equipment, you can see. So these clauses here in these clean air regulations cover almost every single trade and industry. As long as you generate any form of air pollutant, you are covered by this act. So therefore, I think it's very important to realize that you don't play some ignorance that, oh, no, it shouldn't apply to us. No. One day the law will catch up with you. Next. Okay, the emission requirement, currently the regulation for a number of industries require about 150 milligram, but eventually it will be reduced down, further down to about 50 or even further down. As you know, the Clean Air Regulations was enacted in the year 1978. So it's more than 30 years, it's about 35 years now. It was the first regulation until today, has never been changed. So it's high time. I think DOE is already talking about it for the last couple of years. So it's a matter of time, a couple of months later or so, the new regulations will come into force and it will be much more stringent. Right? So in the advanced countries, they are talking about 5 milligram. You know, in countries like Germany, Sweden, Japan, and Korea even, or even China now, they are talking about 10 milligram. 10, some even down to 5. So you can see that we are very lenient, you know? 150 milligram compared with 5 milligram. Imagine how many times? 30 times, huh? Okay, I'd just like to quickly go through with you some reference plants that we have done in the past. So this is for lead smelting plant. This is the complete system we have done for some lead smelters in Malaysia. This is actually incineration plant for this quality alarm, QA, quality alarm in Bukit Nanas. So we have helped them to do an expansion of their existing air pollution control equipment. This is aluminum melting plant. Small incineration plant. I think this is for one of their R&D project. Refuse derived fuel waste to energy recovery plant. This is your plant in Semenyih. Well, anyhow, I think they don't operate this anymore. Right? This is a dust collecting system. You see, this is the big dust collector here. There's one small unit here. There are 2 units we have installed for Mega Steel in their lime kiln in the Bantin. So this is quite an interesting job for us. It's very tall. Brass smelting plant. One of the Korean company invested a brass smelting plant in Malaysia, and we helped them to install this system. You can see this is red hot. Red hot. This is red hot. This is about 700 degrees C. So imagine that temperature is very high. So you cannot stand too near. Right? We just suck the dust, the fumes, even the flame into the system. And from there we go into our chamber, cooling, and so on and so forth, right, before you get out of the atmosphere. Okay, this is a system outside, actually, you can see. Cyclone, radiant cooler, back filter dust collector, fan, and chimney. This is for lead smelting plant. This is one of the biggest, probably they are the biggest lead smelting. That means they break down the battery. They recycle the battery, the old used battery. They break it down, they take out the lead separator, and they melt it in the furnace to recover lead. You know, battery you need lead to make, right? So this is in the process of smelting the lead plate. They generate a lot of dust and fumes, which is very, very toxic. You know, lead oxide is very toxic, very poisonous. So we help them to design and build a complete system for the dust control. For rubber band, this is a scrubber from one of the rubber industry in Malaysia as well. This for copper melting plant is a Venturi scrubber combined with a packed tower scrubber. Food industry is also a scrubber. I think there are a few scrubbers we make for them. Aluminium plant again. Next. Steel wire industry. Drawing. Aluminium. Okay. Aluminium rim. You can see here, these are the explosion relief panel in a dust collector. Just in case if there's any explosion that occur along the line, this will give way first. Thus, it will protect the backfilter dust collector. There was a case, I think, in the north, near the Penang area. There was about, what, 2 3 years ago. It was a big explosion that caused some injury, luckily no death. And the neighboring factory opposite, the glasses were shattered. Good afternoon, Dato. Thank you for coming. This is a pollution control system for pipe coating plant. We have done quite a number of them for the oil and gas industry as well. It's for chemical plant. You can see all the blue ones were done by us. It's an agricultural chemical plant in the north. This is the 2 units of the electrostatic precipitator we have done so far. This is installed in Samsung Corning in Seremban. So we did complete electrostatic precipitator. This is the unit. We have a conditioning tower, then followed by the electrostatic precipitator and the 2 big chimney and the big fan and so on. So this is a good project for us. It costs about, I think, 5 or 6 million ringgit. All right. A little airtime for me. We say that Master Jaya is your most reliable, responsible and competent partner because we are able to offer you a total solution provider for air pollution control system. We are a one-stop shop, one-stop center or one-stop shop for air pollution control. That means you come to us, you don't have to go anywhere else. Just stop at our place, Master Jaya, we solve your problem. Because we undertake complete turnkey means we design, manufacture, install, test, commission, offer after-sales service, get the approval for you from the Department of Environment, give training to your people, offer spare parts, upgrading, modification, whatsoever. Right? Total solution provider. And we have done more than 1,000 installations so far all over the world. And we have got 30 years of proven track record of success. Right now, we are already exporting to all the ASEAN countries. Recently, we exported to Russia, exported to England, to Austria, also, of course, to Africa, and so on and so forth. So we are trying to increase our export more and more as years go by. So, no, anymore? All right, I think we have come to the end. Think clean, go green, and so on. Okay, now questions.
So it's now to the ground, questions.
Yes, please.
I'll hand over the mic to you.
Hello, a very good afternoon. I have just what do you call a question? I mean, question or some opinion, because by looking and hearing from your presentation just now, I must say that your air pollution control system is very good, effective, and can help the country a lot. Yes. Of course, and also whether this system really go in line with this carbon emission 40% intensity that the government is looking forward to meet by 2020. Yeah. Thank you.
Well, I am not too sure whether we will contribute towards the carbon emission reduction, but what I can see here, as you can see very clearly, is that we are able to help to reduce the air pollution level, right, to comply with the regulation, the emission standards. Because when you clean the air, we are talking about cleaning the dust particles or the gaseous pollutants, but we are not removing the CO2. The CO2 is still coming up. I have a friend who is expert in CO2, carbon capture here, right? So maybe he can talk about it later. I'm not too sure about this carbon credit thing, carbon credit or carbon emission reduction. Because carbon, they are talking about CO2. Basically, it's talking about CO2. Of course, in any combustion process, you generate a lot of CO2. right? But it's still coming out. You know, we look at a big power plant, power stations. Look at all the big boilers. There are many boiler people here. The big boilers, they are coming out with CO2. But at this moment, sorry, we haven't got the know-how or technology to capture the CO2 yet. I think it is another level of technology if you talk about capture of CO or CO2. Right? Thank you. Thank you for your question. Yes, please.
I am from Sri Lanka. I want to find out what the technology available for the removal of volatile organic carbons. Yes. Because you did not address that in your presentation.
Thank you. Wonderful question. What is the technology available to remove volatile organic carbon, VOC? We have already done several in Malaysia. I would like to quote one very good reference plant that we have done for Singapore. You know, Rolls-Royce aircraft engine manufacturer. They set up a huge plant in Singapore, and we were very honored, privileged, and lucky to be awarded this order to do a VOC control system for them in Singapore. And we were competing against all the world players in the field of VOC control. And we have done what we call a thermal oxidizer, right? A thermal oxidizer to remove the VOC. Basically, what it does is to destroy the VOC by burning. So you just burn it off.
What is the temperature?
Temperature can be as high as up to 800 to 850 degrees C in order to burn away all the VOC, you know.
So
because
you have a heating system like burning device?
Yes. We have a burning device. At the same time, we have a heat recovery system. Because it's very important that we must ensure that we don't consume too much fuel in the course of destroying the VOC, right? So the emission standard is very stringent, not only for Singapore, because you know Rolls-Royce has been a world-renowned aircraft company. They're very, very particular and very concerned, very demanding in terms of emission standard. So we have to comply with the world standard, you know. So it's not easy for us to give the warranty against emission. And they even put up a continuous monitoring system at the stack to monitor the VOC level at all times. So anytime they can just take a look at the screen, at the monitor screen, and say, yeah, this is what level. So that is the VOC has got a number of technology. This is one of them. So you can have
activated carbon filters. Is it effective? Activated carbon?
Yes, of course. Yes. So to control VOC, you can use activated carbon, right? Activated carbon column or activated carbon filter. You can use the thermal oxidizers with catalytic and so on and so forth, regenerative, catalytic, all different types of thermal oxidizers. And you can also use gas scrubbers, chemical gas scrubbers to remove VOC. You can also use bioscrubber, over biological, using the microorganism to remove the VOC and so on.
Has it been implemented, these bioscrubbers and chemical?
Yeah, it's all available. The technologies I mentioned, they are all available in the market, in the world, and some of them already in Malaysia. We have also a number of them with us. So it's not a problem. I think as far as air pollution control is concerned, I think I want to claim that we are able to do most of it, almost any kind of processes. We always want to take a challenge. Even certain processes that we have not done before, we also like to take a challenge to do it. To say that, okay, we will take the challenge and do it for you. Thank you for the question.
Another question, that for the chimney height now, for the biomass boilers, for the height also, do you all have any guideline in Singapore to specify the height depending on the boiler capacity and the consumption rate? There is a guideline.
Okay. I understand what you mean.
Yeah.
She is asking about the boiler height. Huh?
So
boiler height, are you from Malaysia?
No, I'm from Sri Lanka.
Ah, no wonder. Okay, you don't understand the Malaysian standard. He is from Sri Lanka. Okay, very simple. Our standard norms is not actually black and white. It's not actually stated in the form of regulation. But most of our DO officers will say that we want your chimney height to be about 3 meters above the highest point of your building. The apex of the roof plus 3 meters. So if you have a high roof of 50 meters, your chimney must be at least 53 meters. So if you build your building low, of course, you also talk about the surrounding building, the surrounding area of maybe, so on. Okay, more? Can you allow others to have a chance to ask some questions?
No, because if you do have any questions, I think the booth is just behind there. So you can have a private session with him.
My booth is at the back. Please come over anytime. Free consultancy now.
Yeah,
for today only. Yeah?
Okay, thank you so much for the question, and thank you so much to AK Wu for the sharing. Yes, thank you.
Thank you very much. Thank you.